Hello faculty members and viewers. Welcome to our project presentation on Mechanizing the RASA KALPA process. This project is completed by Mr. Nevron Albuquerque, Ms. Bhageshri Ingle, Ms. Priyanka Ladole, and Mr. Abhishek Rao, under the guidance of our college professor, Mr. Sri Prasad Manohar. We had visited an Ayurvedic industry named Abhiyankar Private Limited, which looked after the making of a number of Ayurvedic medicines, which is either in the form of liquid or tablets. While on our visit, we came across a lot of Ayurvedic processes which were mechanized except for one Ayurvedic medicine called the bhasma. The process that was used was called Rasa Kalpa, meaning juice extraction. It is a process of making an extract out of raw Ayurvedic materials. This is done so as to get the required gun in them. The extraction helps in the formation of bhasma, which is obtained after drying and in powder form. This process is done in a stone vessel with a pre-made powder added in it and a sprinkle of rose water to help in the paste formation. Now, using a stone ladle or pestle, this is grinded for 8 hours per day for 15 days, so as the bhasma which is formed is achieved at the end. After this is done, it is kept for drying and small tablets are made out of the bhasma prepared. The idea of mechanizing the process was needed because it has increased labor cost, which increases the cost of medicine. Therefore, it will not only reduce cost but also save time. The process of bhasma formation. At first, selection of raw material is done, after which identification of purity from the raw material is done so as no defective or spoiled raw materials enter into the bhasma process. Then washing and cleaning is done thoroughly so no impurity is left behind. Grinding and making of fine powder. This is the Rasakalpa process which is performed. It is done with mixing a herbal juice or herbs. This is the traditional process, but for our project, we use rose water for the preparation of the paste. Again, the grinding is done with herbal juices for 10 to 100 hours in the traditional Ayurveda process, but the industry that we visited takes nearly 360 hours or 15 days for the grinding. After the paste has formed, they are made into small tablets. These small tablets are then kept for drying.
Methodology. Methodology which we accepted for getting our final products design includes three phases. Phase 1 includes determining the similar motion mechanism which are already available, which includes 4-bar mechanism like slider crank mechanism, quick return mechanism, crank and rocker mechanism, and wiper mechanism, whose pictures are shown as below. These mechanism traces the basic manual motion which was used to make the bhasma as we have seen in the industry. Phase 2 includes system concept design. So the first model we designed was 4-bar mechanism with boat-shaped stone vessel. Advantage of this model was easy to manufacture, manufacturing cost was low, and vessel can be removed and placed back easily. Disadvantage of this model was the batter needed to be collected at the center of the vessel by hand. Product formed is coarse. Production time for product is more. Power consumption to output ratio is high. Dimensions of links are large. Therefore, the machine becomes bulky. Second model which we made was wiper mechanism. Advantage of this mechanism was similar to the previous mechanism, which includes easy to manufacture, low manufacturing cost, and vessel and hull can be removed easily and placed back. Drawbacks of this mechanism was wear of vessel was more, dimensions of the links were larger to get the angle of sweep to achieve the required angle of sweep. Third was the slider crank with pulley reduction mechanism. Advantage of this mechanism was cost of motor was reduced. It is easy to manufacture. Force exerted was more Vessel can be removed and placed back easily like the previous two models, and maintenance was quick and easy. Disadvantage of this mechanism was batter needed to be collected at the center of the vessel by hand. Dimensions of connecting rods were large, therefore machine got bulky. There was slip between belt and pulley, therefore power loss used to take place. Um, slip increases with the load application, and wear and tear were more. Therefore, considering all the drawbacks of previous three models, we designed the final model. Construction, working and assembly of this model will be explained in further slides.
Now we see the construction of a final model. It consists of a mortar and pestle assembly which was made of hard stone. The mortar and pestle are used to crush the substance and not be worn away. We use the mortar mount and pestle mounts which are fabricated as per the dimension of the mortar and pestle and act as fasteners. We use two pairs of spur gears and a pair of bevel gears consisting of bevel pinion and bevel gear. All these are attached to the frame, which is made compact. Now we see how a model is assembled and disassembled. Here is the disassembly of a model. We can see part by part how it is being disassembled. Now it is being assembled back. Now we look at the working of a model. At your left, we can see a shaft which is connected to a spur gear pair. When the motor is switched on, the spur gear pair starts rotating and transmit power to the next spur gear pair, which in turn transmits the power to the bevel gears. The bevel gear is connected to the vessel attachment, which helps it rotate. The other side of the same shaft is connected to a cam and link type setup, which helps rotation of the hull portion of the assembly.
Motor selection. To avoid spilling of batter, we kept the RPM of hull as 15 RPM and vessel as 10 RPM. For this, we needed a motor with low RPM and high torque. Therefore, we had purchased a gear motor with 250 RPM. To step down the speed, we chose spur gear pair for hull and bevel gear pair for vessel. By considering the speed and torque of motor, we calculated the module of gears as 2 mm. Considering the speed of rotation and shaft size, we had selected a deep groove ball bearing with series 6410. To achieve required motion of hull, we had chosen this 4-link mechanism. By considering the size of purchased hull vessel, the maximum angle of sweep by hull can be 64 degrees. According to this angle, we had calculated the remaining dimension of links using trigonometric relations, as shown. As the vessel is rotating about its own axis, which exerts centrifugal force, which can throw the batter out of the vessel. But as the consistency of batter is thick and RPM of vessel is kept as 10 RPM, that is very low, there is no problem as such. As both hull and vessel are moving simultaneously, here the concept called relative velocity come into picture. We had calculated the relative velocity and force exerted due to it as shown. This force gets added to self-weight of hull and helps in crushing the batter.
Result. After the survey and visit at Abhyankar Ayurvedic Private Limited, the problem the workers were facing with the Ayurvedic process was identified. According to the selected problem, 4 solutions were designed using the SolidWorks software, and the most optimum and effective model was selected and fabricated. Certain modifications were made pertaining to the defined problem to the selected model. In the final prototype, the output was achieved as needed by the end user. The final model was cost effective and medium heavy in weight. A positive response was received by everyone at Abhyankar Ayurvedic Private Limited after the final testing. Thank you.